Alright, so today we're looking at solving trig functions, day 2. Go over some questions from yesterday in class, make sure we're on the same page, and then now we're going to get some more complicated solving, basically, like factoring and quadratic. And basically yesterday we did the simple stuff that was like algebra 1 equivalent type solving. Now we're going to get to like algebra 2 type, where you just actually have to factor to solve, quadratic formula to solve. Here's what you can expect. You can pause and read through that. I'm not going to go over it, but that's what a chapter 6 is like, test is like. Alright, so we're using a calculator here to solve this. So once again, what we have to do, you have to take the sine inverse of both sides, because we talked about inverse function with a regular function basically cancels it out. So we take the sine inverse of both sides. Now, remember, this is giving us a reference angle. So you do the sine inverse, and you will end up with negative 23.58. And we usually just go to 2 decimal places there. So remember, this is a reference angle. This isn't your actual solutions, because as we talked about from the last section, you have to pretty much crop the inverse function in order for it to be a function. So now what we have to do is we have to figure out where sine's negative, and then find our answers from there. So we know sine should be negative in 3 and 4. So this is a reference angle, so that's 23.58. And this one here is 23.58. Same number. So if you remember from reference angles, you're going to the nearest x-axis. And so when you solve those, you will end up with 203.6 and 336.4. Alright, this one requires a little bit more solving. So pause the video, try it on your own. I want to put the answers up here, so that way when you play it, you can see what you do if you came up with the right answer. Alright, so you end up with a 138.59. Now remember, that is just a reference angle. In this case, it's actually also one of your solutions. You have to then determine the reference angle from this to get that guy. So to do that, you're drawing it out. And if that's 138.6, and that's 180, you have to subtract them to find that angle measure, and then plug it into quadrant 3, where cosine is also positive. So take a second and recall this stuff. You can pause the video and look at it real quick. Basically just a quick recap of how to factor, or basic factoring. So in this, now we're solving by factoring. So in this case, what you're looking at is this is a difference of squares, where this is a cosine squared, and that's the equivalent of saying 1 squared. So how that factors is you would end up with a cosine squared of theta minus 1. Oops, that's not a square, sorry. You end up with a cosine of theta minus 1. Then you also end up, that yellow doesn't show well. It's a cosine of theta plus 1 equals 0. So then when you're solving with factoring, you have to set each of these equal to 0, and then solve them independently. So you'll end up with a cosine of theta minus 1 equals 0. And you will end up with a cosine of theta plus 1 equals 0. So if you go through and solve, cosine of theta here would equal negative 1, which in this case that is on the unit circle, so I would hope you would remember that that would end up being 180 degrees. If not, you could plug in your calculator, but this would be an example of a problem that would be in the no calculator section of the test. So here you have cosine of theta equals positive 1. So once again, I would expect you to know that because it's on the unit circle. And cosine of theta equals 1 at 0 degrees. So now you have those two solutions. Alright, one thing we can do here, when they start to get more complicated, one thing that helps is saying, okay, instead of keeping these as sines, let's put it in terms that you're more familiar with. So let's write them as x's, because sometimes that just makes it a little bit clearer as to what we're dealing with. So once again, sine it, we have 2x squared minus x equals 0. How you factor that? If you recall, this is the greatest common factor of x, so that's a 2x. Now don't forget, if you take an x out from there, you have to have that placeholder, which is a 1. So then that equals 0. So now you have your two things being multiplied together. And so when you're solving by factoring, you're splitting those up. So x could equal 0, and the next part would be 2x minus 1 equals 0. Now, when you're at this point, on this side, you can plug the sine of theta back in for x. Usually what I would do is I would wait until you have the x all by itself, and then plug it back in. So here we have x equals 0. So sine of theta, therefore, equals 0. And so hopefully, once again, this is an exact value from the unit circle. And hopefully you would know that sine equals 0 at both 0 degrees and 180 degrees. Alright, so we got the first set of answers. Now we go to the second problem. So we're adding 1. So you have 2x equals 1. Divide everything by 2. So that should be an x. X equals half. So now you have the x by itself. Let's put the sine theta back in for the x. And, you should probably recognize that from the unit circle. So sine equals 1/2 at 30 degrees and 150. And once again, if you're not sure where those are coming from the unit circle. So you would be looking at your y coordinates in the two quadrants, sine's positive, which is in quadrants 1 and 2. Alright, so last but not least, we have one with the quadratic formula. So in this case, just like in Algebra 2 when you're solving complex or more complex equations, if you can't factor it or you don't know how to factor it, you can always use the quadratic formula. The reason why I wouldn't recommend doing it that way is that, as you probably remember, the quadratic formula is fairly tedious and kind of obnoxious. So what I'm going to do in this case is I'm going to work it out and just kind of step by step work it out so you can see where all of this is coming from, and hopefully it makes sense. You probably won't hear me too much, so I'm going to probably be more focused on working it all out, and then we'll talk through it here in a second. So as you're following along, I'm running out of time here, which notice no solution here because that's outside the range of sine. Remember, sine has to be in between 1 and -1, and that's -1.65. Hopefully that makes sense. We'll spend some more time in class, but otherwise, I'll see you next time.